Left class, I want to look at this topic in mathematics, circle geometry. And this is one of the interesting topics we have in mathematics. And the first word we have here, circle. We need to know what a circle is. So when we say circle, what do we understand by the word circle? A circle can be described as locus of points. I say locus of points which is equidistant from a fixed point. So this is referred to as circle. That is, we have a fixed point. Let's call this O. And we have a distance. This distance is called R. So this locus equidistant from this fixed point O, this locus of points is what is referred to as circle. So this is the definition of a circle. And also, we can consider some parts of a circle. Like we have radius. I say first one, we have radius. Then second one, we have diameter. The third one, we have a chord. The fourth one, we have an arc. The fifth one, we consider what a sector is. And the sixth, what a segment is. Now, this part of a circle is important for us to be able to recognize before we solve questions on circle geometry. Now, what is a radius? A radius is just the line drawn from the center of a circle in circumference. For instance, if we have a circle, let's say this is a circle with center hole. We have this circle with center hole. The line drawn from the center to any part of this circumference, this is circumference here. Distance around the circle is called circumference. So the line drawn from this center to any part, the circumference here, this line is called a radius. We can draw it to any part. Might be towards this side, it's still a radius. Once it is drawn from the center of the circumference, that's a radius. Alright, and what is the diameter? The diameter is a line drawn, passing through the center and touching the circumference at two sides. Passing through the center. Now, you might decide to draw this line that will pass through the center and still touch the circumference at this side. So if I draw this line straight out, touching at this side now and at this side, this line drawn now is a diameter. And from there, we discover that center to the circumference is a radius. Center to the circumference here is also a radius. So which means diameter is now 2 radius. That's R plus R. That's 2R. So diameter is equivalent to 2 radius. Okay? So, and what is a chord? When we talk about a chord, let me draw another circle here. We have this circle with center O, and a chord is just a line that touches the circumference at 2 points. Now, this is not necessarily passing through the center, but it's touching the circumference at 2 points. For instance, we can draw it anyhow we like. We can draw it this way. So this line touching on this side, touching on this side. So this line is referred to as a chord. It might be at any part. You might draw it this way. It's still a chord. You might draw it anyhow. So once it touches the circumference at both sides, it's a chord. Now we look at diameter also touch at both sides. So diameter is also a chord, but a special kind of a chord, which you can call the longest chord of a circle. So diameter is referred to as the longest chord of a circle. All right. Now, what's an arc? An arc is just a part of circumference, a part of the circumference. That's an arc. For instance, we cut any of the circumference, we cut any part of the circumference like this, and cut this, which look like this. So this part is an arc. Of course, we can label here from here to here. I label it as AB. So from A to B here, this curve here is what is called an arc. So that's an arc. An arc is a part of a circumference, okay? Now, what's a sector? A sector is a region between two radii and an arc. Two radii and an arc form what is called a sector. For instance, here, this is a radius here. This is also a radius here. And this point A to point B is an arc. So this region here, bounded by these two radii and this arc AB, is what is referred to as a sector. So this region here is now called sector. And that give us two sector now. The one shaded here is a sector. The bigger one that is not shaded, that comprise of this big arc with these two radii, is also a sector. But one is minor sector. The shaded one is minor sector, and the shaded one is major sector. So that's a sector. Then for segment, a segment is a region as well, but is bounded by a chord and an arc. Let's look at it at this side. We have, let's label this as AB. From A to B here, we have this as arc, and we have this as chord. Then this region here, bounded by, okay, we label this as B here. Bounded by this chord and this arc is what is called a segment. A segment. Okay? And the one not shaded that contains the bigger arc here is also a segment. Why this one is major segment, this one is minor segment. So these are some parts of the circle that we need to understand before we move proper to what is called circle theorem. You are watching us live here at Master T Math class. So do well to connect to the end of this class and also subscribe to this channel in order not to mix out on our uploads. Then I want to look at, before we go to the circle theorem proper, there's something called lemma. That is the prerequisite before theorems. Those things we need to know. That is the basis or some derived principle that we need to know before we dive into the theorem proper. Now let's look at number one. We discover that when we talk about a chord subtend two angles. A chord subtend two angles at the center of a circle. Now, this word subtends in mathematics is similar to the word formed. Formed. A chord can form angle at the center, but that will be two angles. Let's look at when we have it in diagram. We have this as a circle, and let's look at this as center hole of the circle. Okay, that is, we now talk about a chord. Let's call this as a chord AB. Then this chord now, we have the first point here, the second point here. Now form two angles at the center. That is, we connect this point A to the center, also point B to the center. And we have this angle here, and we also have this angle here, making two angles at the center. One is inside, one is outside. The one inside is called obtuse. Obtuse angle AOB. We use three letters whenever we label angle. And the one that contains that angle will be at the middle, connecting the other 2 points. Okay? Obtuse angle are angles that are greater than 90 but less than 180. This angle here might be greater than 90 degrees or less than 180 degrees. Okay? And also we have the reflex angle AOB, the one outside. That angle is greater than 180 degrees but less than 360 degrees. Okay? So that is that. Now, that's the first thing, very important, that a chord subtends two angles at the center. Now, also, the second one, we have a chord subtends two angles at the circumference. Now, at the circumference of a circle. So when we have a circle the same way, and we have a chord, the center of the circle, we have a chord, we call this chord AB. So this chord can form angle at the upper part of this, that is, at the major segment. Now, it can form an angle at circumference at any part of the circumference here. You can call it as C. So we have this as angle ACB. And also can form angle at the other side, which is at the minor segment now. We can call this D. So we have two angles at the circumference, one up and one down here. So we can say we have one angle ACB, which is the mark one here, and also angle ADB, which is the marked angle here. So we need to understand this. This will form the basis for the theorem we are about to look at. And in the same way, we discovered that diameter can also form angle at the circumference. Diameter subtends angle at the circumference. We can abbreviate circumference like this now. And that angle subtended at the circumference by diameter is, of course, will be angle 90 degree. It's a theorem on its own. So let's consider this the diagram. We have the circle center hole. Don't forget that this center here, a line passing through it is the diameter. So this line AB here is the diameter. And this diameter, has divided this circle to equal part now. So whichever way we draw it, the angle formed by this diameter now is the angle subtended at circumference by diameter, and this angle will be 90 degrees. It has its own proof from the theorem. So these are the major things we need to take note first before we start proving the theorem now. Now we look at the first theorem, which we are going to label in this class as theorem 1. So we have theorem 1, and this theorem states that the angle subtended by a chord or an arc, theorem 1, states that the angle subtended by a chord or an arc, we might use arc instead of a chord, or an arc at the center of a circle is twice that which it's subtends or subtended at the circumference of the circle. Now, very quickly in this class, we want to look at the proof of this theorem. It has a proof, and once we are able to prove this theorem, it's like the foundation of circle theory. We are going to be able to know and recall all other theorems which will be applicable when we are solving riders under geometry. Now, the theorem states that the angle subtended, the word subtended is not new to us again. That's the one formed, okay, by a chord or an arc. Is that we're referring to a chord or an arc at the center. So we have the key word here, we have a chord. The center of a circle is twice. So this word twice is a major word, key word. The angle at the center is twice that which it subtended. So let's put the word which here. That which it subtended at the circumference. Circumference here is also a keyword of the circle. Now, before we prove the theorem properly, we list what is given out. It's part of a proof, okay? So we can say given on the theorem. What are those things given? One, we say a circle with center O. Oh, sorry, light out. That's break in light. Sorry about that. So please, if you don't mind, we continue this class later for me to go and get the light set. All right. So I appreciate you for connecting. Why not subscribe so as not to miss out by the time we go live again? And stay tuned. See you next class. And bye for now.